All right, welcome everybody to the 2024-2025 Colorado ENP Study Session Series. We are so happy to have you join us, and we are grateful to our first instructor, Michael Berry from Summit County. He's going to walk us through the first session. Before we get going with that, though, I want to introduce Connie Johnson, the Executive Director of the Colorado 911 Resource Center, and I think she's got a few words for us to kick us off. Connie?
Well, my few words to kick us off is welcome, everyone. Thank you for taking the time and participating in this. Thank you to Michael for taking on the first session, Jennifer and Daryl for spearheading this. And again, we will have this on the website as a finished product. And the last session series was so well received around the country. Looking forward to how well received this one will be.
Awesome. Thank you so much. And I am Jennifer Kirkland with the State 911 program, and I have Daryl with me, Telecom Program Section Chief at the PUC. And Daryl spearheaded the first round of study sessions and was instrumental in getting the second round up and running. So thank you to Daryl for that. Before we get started, I'm going to throw actually I'm going to ask Michael to stop sharing for a minute, and I'm going to share my screen and show the website where you can go to find out about ENP certification. So that would be the NENA website, and it is nena.org in the training and ENP certification. So this is your homepage for everything to do with ENP certification. You've got the program overview here, and if you scroll down, it goes through all of these headings, the eligibility requirements, exam dates, and so on and so forth. Michael's going to talk a little bit about where to get the study guide if you don't already have one, but calling attention to exam dates here. The winter exam schedule is open from January 25th to February 8th, so that time period will close before we finish our study sessions. But if you are interested in taking it, then the application deadline is December 20th. So that's coming up in about a month. So you've got a little time. And if you'd rather wait and finish out the study sessions and take the exam in the next round, that will be April 5th through April 19th. And the application deadline is March 7th. So everything to do with ENP certification is here. And I will stop sharing and give it over to Michael and kick it off. Take us away, Michael. Thanks so much for being here.
Thank you, Jennifer. Thank you, Connie and Daryl, for setting this up. Get this reset. And thank you, everybody who is dialing in, participating for this. I'm so happy to be here. Thank you to the Colorado Training Standards Institute for putting this together. As Jennifer said, my name is Michael Berry, and I am your presenter for today's class. A little bit about me. I am currently the director of Summit County 911 and an ENP myself. I started dispatching over 20 years ago, and I am thrilled to be here with you today. So this is session number 1 in our refreshed CTSI ENP study sessions. As Jennifer and Connie said, these are being recorded and will be available online for all to see. I encourage you to refer back to them while you prepare to sit for your ENP exam. Today's class is Intro to the Psap, and we'll be covering sections 2.8, 2.6, and 2.7 of the ENP study guide. First and foremost, this is your time. This class session is as interactive as you want it to be. So feel free to raise your hands, put a question in the chat. I'll do my best, and Jennifer's going to help me to monitor that so we can pause, take questions, make sure everybody's following along and understanding, and we'll have another chance at the end as well. If you haven't already, I highly encourage you to purchase a copy of the ENP study guide and download the ENP Book of Knowledge from NENA. Jennifer put up that page. You can also see the link to the ENP study guide. The current versions are 6.1 of the study guide and 7.0 of the Book of Knowledge. Not only is it just great information to have, but obviously it's also the basis for a lot of the ENP test questions. Session 13 will go into a lot more detail about the testing process and what you can expect, but this is a great way to start and to follow along. I will acknowledge, particularly in some of these sections, there's a lot of information that many of your agencies, it's no longer as current for. We'll be discussing the 911 system as it was and as it has been for many years. And there's a lot of places where this still applies today. But for most of our agencies in Colorado, the journey to the next generation 911 environment has already begun. Recent rulings with the FCC will only be accelerating that. But this is still good historical information, shows us where we came from, where we're going, and because there are a lot of questions on the ENP exam that you'll have to know for it. With that in mind, you will notice when I said the sections, we're not planning on going in the order of the ENP study guide for this session. And I'd like to start with a little more high level, looking at the overview of PSAPs first, before we get into some of the finer details of the features and the equipment. So with that, let's get started with our overview and intro to the E911 PSAP. So PSAPs come in many shapes and sizes. There is no one size fits all model because every jurisdiction that's covered could be covered by one or more PSAPs. Now, before we get into the PSAP models, let's talk a little bit about how that call or text gets to the PSAP. So here we have a very oversimplified depiction of a typical call flow from the caller to the PSAP. You'll find more detailed diagrams in your ENP study guide, specifically on page 47, if you have those with you. Again, I want you to keep in mind that with Next Gen 911, a lot has and will continue to change, but the general idea behind a 911 call still stands true and is what's important here. Like any other call or text, the connection first has to hit the phone provider system and be routed over to the 911 system. From either the local end office for landline or Voip calls, or a mobile switch center for wireless calls, that signal will be forwarded to what's called a tandem office with a selective router. We'll be talking more about that later in today's session, and much more about that in some of the future sessions. Again, we're looking at an overview for today. In the legacy system, the selective router will check that phone number against a database and decide where to route that call, which PSAP to send it to. For wireless calls, the phone number is assigned to the cell tower, and that's what's used in that routing. From there, the signal essentially splits into two paths, one for the voice or audio and one for the 911 data. That voice path will be sent to the designated PSAP, while the data, the phone number, the tower designator, that's all forward to ANI and ALI controllers, and for wireless calls onto a mobile positioning center. Those functions search the details of the phone and then forwards that back to the PSAP, to the call handling equipment, and it marries it back up with the voice signal in the call handling equipment so you, the telecommunicator, can be served up with the ANI and ALI information that you'll see on your phone's display. Again, you'll get a lot more details on these external parts, particularly in session 3, where we discuss the 911 networks and the migration to Next Gen 911. But for today, the important part is that overview, understanding how the call gets from the caller to the PSAP and how much is happening behind the scenes in order to get it to that correct PSAP. But what is a PSAP? PSAP is an acronym for Public Safety Answering Point, and you'll get a lot of acronyms through the course of these sessions. In basic terms, a PSAP is where the 911 call goes, and there are various types of PSAPs based on a combination of factors. Notice how I've not mentioned anything about the type of public safety. Police, fire, EMS, that is not what is important in the PSAP naming and environment. It's a matter of how and for whom you're answering the phones. First is the primary PSAP. And as the name implies, the primary PSAP is a primary receiver of 911 calls. When you dial 911, the call should be answered by a primary PSAP. Depending on how your jurisdiction is set up, that call may need to be transferred to a secondary PSAP. Secondary PSAPs only receive 911 calls either transferred from a primary PSAP, or they could be used as an overflow in a call routing scenario. They can be a backup, but under normal circumstances, they would not be the default for answering 911 calls or texts. Now, this is most commonly seen when you have a police or law communications center that's separate from the fire and EMS communications center. The police call takers would be your primary PSAP most often. They'll conduct some initial triage of the call, and if needed, they can transfer that call to a fire EMS secondary PSAP. And that 911 data, it stays in the 911 system and it flows to that secondary PSAP. Now, whether your center is a primary or secondary, if all of your services are being provided within a single jurisdiction, you're part of a single jurisdiction PSAP. This could be a town or a city, could be a county, as long as the PSAP is serving the public safety needs within a single jurisdiction. Could be a center just for local law enforcement, just for fire, just for ambulance, or it could be a single center serving all three of those. In a populated area, you might even find multiple single jurisdiction PSAPs serving the individual towns or cities within a county or a region. You could also have a consolidated PSAP. A consolidated PSAP is a single facility or entity that's acting as the PSAP for multiple jurisdictions. My own beloved Summit County 911, for instance, is a consolidated PSAP. We dispatch for 6 different law jurisdictions and 2 different fire authorities. My center is a county department operating under an MOU with our agencies, but consolidated centers could be managed in any number of ways. Might be a function of the county like mine, a county sheriff's department, or it could be a completely separate and independent entity with a representative board of directors from those participating agencies. Again, it doesn't so matter much what the discipline is, law, fire, EMS, it matters where and who you're serving. Less common, but not unheard of, are the private PSAPs. These are private businesses contracted to act as the PSAP in a jurisdiction or regional area, but they're not public safety entities in and of themselves. Think of an alarm company or a similar call center business. Consider OnStar, for instance. They're not a private PSAP, but they do monitor emergency alerts from vehicles. They monitor emergency phone apps from their subscribers, and their emergency certified advisors are trained in EMD and triaging other emergency call handling scenarios, because essentially they're acting like a primary PSAP for their devices. Now imagine if they contracted with your municipality and took over the actual 911 call taking duties. That would be a private PSAP. PSAPs can also be co-located. This is not the same as a consolidated center though, and it's not an official PSAP type designation. I just want to throw it in there just to make sure we understand the difference between consolidated versus a single jurisdiction, somebody who might be co-located. You might have a single building housing members of separate agencies. For instance, you might have a police emergency communications center on one side, a fire emergency communications center on the other side, and in between them, maybe a private ambulance service dispatch. Each is operating independently from a legal standpoint. They're their own agencies, but they can greatly benefit from employee cooperation, communication, shared equipment, and the building expenses. They're co-located, but they're individual agencies. One more concept to address is a virtual PSAP. Now, this is a relatively new concept in practice, but it's increasingly possible and potentially beneficial, especially thanks to next-gen 911 technology advances. A virtual PSAP moves the call takers out of a dedicated building and places them anywhere in the world. You see this kind of call center set up quite often in the private sector for call centers, customer service assistance, but not as often in the PSAP environment. But think of how beneficial this could be for contingency planning, continuity, disaster recovery, which will be a major topic of our session 4. Another variation on the virtual PSAP is the virtual consolidated PSAP. Each PSAP is operating from their own physically separate center or even from home, but they're operating on a shared infrastructure. They're operating on shared equipment. So that, again, like the consolidated or co-located centers, they're sharing on those costs. So now that we understand how the call is getting in, we're understanding of what our PSAPs are, let's talk about the 911 system, some of the features, and a little history lesson. Prior to the 911 system, the only way to report an emergency was to know your local police department or fire department phone number, or to call a telephone company operator and ask that your call be forwarded. And you can imagine that took some time, and in an emergency, every second counts. So in 1957, the National Association of Fire Chiefs began recommending a universal phone number for reporting fires. A great idea, but it didn't get a lot of traction at first. It would have been a huge effort on the part of every phone company throughout the country, so it took them some time. Then in 1967, the President's Commission on Law Enforcement and Administration of Justice recommended a single universal phone number for reporting any emergency. Essentially the same recommendation as 10 years before, but this time the group had the word president in its name and associated to the president caught a bit more attention. And finally, on February 16th in 1968, the first 911 call was made in Haleyville, Alabama, by a local phone company who was looking largely to scoop that honor away from AT&T. In the early basic 911 model, call routing to the PSAP was decided entirely based on the location of the phone company's central office building, not the caller. It's better than nothing, but certainly not ideal. Those phone company boundaries rarely matched the jurisdictional boundaries, and some callers within the jurisdiction could be getting the correct communication center, while others were sent to neighboring centers. Also, there was no subscriber information. There's no Annie or Allie. The call just came in on a dedicated emergency line. Again, better than nothing, but as we've seen, we can do better. Comparing this to the overview of the system we saw earlier, we can see where this started forming the foundations for the 911 system we know now and how it grew out from there, from the phone through the local office and into the communication center that the phone company decided. Next came basic 911, and this added that Annie and Allie information. The phone companies started including that data with the voice call, adding a phone number and subscriber information. Now, the routing was still based on that phone company central office location, not the subscriber location, but it did give the PSAP a physical location and a callback number that when the caller couldn't stay on the line, they had some place to go to. And remember, this is a time before cell phones, before voice over IP. Phone calls were coming in from landlines. There were some exceptions for business lines, but for the most part, if you got a call from a number registered at 123 Main Street, you had a pretty high likelihood of finding the emergency in or around 123 Main Street. Comparing that again to that overview diagram, we can see the addition of the Annie and Allie controllers and that additional data path making its way into the PSAP. Now, a big jump happened with the introduction of enhanced 911, where basic 911 routed to the PSAP based on the phone company location. This expanded the enhanced 911 routing the call based on the subscriber information. 911 calls coming into the phone company's local office, instead of going directly to that local PSAP, got routed to the selective router, which determined which PSAP was responsible for that subscriber location. But of course, it wasn't as easy as that. GIS and mapping didn't exist the way that it does today. It wasn't as simple as saying 123 Main Street equals PSAP A. That, again, would have been a huge undertaking on the analog phone systems across the country. So they found a way around that to accomplish the same end result by creating a translation database in the middle. First, they determined who the primary PSAPs were, determined each PSAP's emergency service zone, or ESZ, their jurisdictional boundaries, basically, and assigned each of those zones an identifying emergency services number, their ESN. From there, the phone companies and the PSAPs compiled a list of every single address and phone number within their ESZ, their zone. This master list is called the MSAG, or the Master Street Address Guide. Each entry on that list was matched to one of those ESNs. And the end result is that the caller dials 911, the phone company forwards the call through the selective router, which compares the phone number to that MSAG. The MSAG entry provides the ESN associated to that phone number, which is the code, essentially a routing phone number for which PSAP should be handling the call. And the call gets forwarded along the system to that PSAP. And this wasn't just for landlines. You'll learn more about cellular routing in session 5 of our lessons. But in short, an entry in the MSAG for the cell tower designated phone numbers for what allowed cellular calls to get routed to the proper PSAP. And this allowed agencies to designate alternate PSAP routing and selective transfers between enhanced 911 PSAPs, where the Annie and Ally data could be forwarded along with that call audio. Before, in the basic 911 system, there was no forwarding. Whatever PSAP took that call had to continue with it and manually forward that information to another jurisdiction if it wasn't in theirs. And as telephony technology progressed, the 911 system had to progress with it. There were landlines and then cellular phones. The next major technology to make things difficult on the 911 system was voice over IP, or VoIP. These are systems that use the internet instead of traditional phone lines. Think of your Skypes, Zooms, Vonage. In a time where long distance calls were expensive and you needed a separate add-on phone plan, these companies started leveraging internet technology to upend that trend. One of the benefits of these systems was that you could take that phone with you anywhere in the world. And as long as you could connect it to the internet, you could make a phone call. So what happens when you dial 911 and they don't know where you are? Well, that depended on the provider. Some systems can only call other VoIP lines within their network, in which case there is no 911 service. They don't have to have that. But if the VoIP service allows any calls to be placed outside of their network and into the standard phone system, they must, by law, provide an option for 911 service, thanks to laws like Kerry's Law, Ray Baum's Act, and other FCC rulings, which you'll learn about in session 12. For today's lesson, we need to understand some acronyms behind this: VSP, VPC, and ESQK. As we go through them, you might notice some similarities to what we've been discussing in the traditional phone companies. So your VSP is your VoIP service provider, basically your phone company. By law, they must be able to route those 911 calls to a call center. Now, that call center could be their own, but for most VoIP providers, that's a cost they'd rather not have to handle. It's more cost effective to go through some technological hoops and get a proper 911 routing solution baked into their system rather than have their own call center. And for that, users must volunteer the locations of their equipment and keep that location up to date. Enter your VPC, your VoIP Positioning Center. This is where they have a record of what location your VoIP service is registered to. So when a user calls 911, their system checks your VoIP line against their VPC and routes it based on the location you've given them, kind of like an MSAG. Unlike your MSAG, that record is going to include an Emergency Services Query Key, or an ESQK. That ESQK helps the selective routers piece together the information to eventually get to the point where they have an ESN where they can properly route you to the 911 call to the Psap that it needs to go to. All right, so we've got our calls, we've got our Psaps. What other equipment might we be using in our Psap? So the most important equipment, especially in our case, is the call handling equipment. You might also hear it called the call processing equipment, or CPE. And in call handling equipment, you generally have two options. You can have on-premises or you can have hosted. While hosted is seeing an uptick lately, let's start with your on-premise, since this is really still the default. In a legacy system of copper wires and analog lines, the phone company would have delivered that 911 call and anti-alley information over a CAMA, an MF, or an EMF line. Again, we'll get into much more details about that in the 911 technologies in session 3. On-premises means that you are in possession of that hardware. It is on your premises, most likely in your call center in a back server room, or at least located somewhere within your jurisdiction and connected to your network. There is hardware in hand you could touch. Those CAMA trunks, those 911 lines running from the selective router are running directly to your hardware. And from there, it's a short hop out to your phone screen at your console, serving up that Annie and Allie information as you answer the call. In a hosted configuration, it's not terribly different from the end user standpoint, but it is very different on the back end. Rather than having hardware on site in your direct control, the lines from the selective router are being pointed at a cloud provider's network. Think of your Amazons, your Googles. One major benefit of a hosted solution is that the cloud provider could be serving up multiple Psaps using those same cloud services, saving money and overhead. In either configuration, your call handling equipment could have any number of additional optional add-ons. One feature you might see regularly, particularly in large centers, is the automatic call distribution, or ACD. With an active ACD system, the system is monitoring who and when calls are being answered, and is going to try and proactively determine and distribute who gets the next call, which telecommunicator gets the next ring. Rather than a general ring that any telecommunicator can elect to answer, the system is essentially telling which dispatcher that a call is coming in and will open that line automatically unless there's some intervention or interaction to stop it. Another feature you will definitely see is the TTY or TDD functionality. Now, Title II of the Americans with Disabilities Act requires that all Psaps be capable of accepting TTY and TDD calls and having telecommunicators conduct periodic training and self-evaluations to make sure they understand that technology. Texting to 911 is great, but it does not replace this legal requirement that we'll talk about in a future session of legal requirements. So what else do you have in your centers? How about we have some audio recorders? Chances are every phone line and radio channel in your center is being recorded. You probably have the ability to play back some short-term recordings through an instant recall function. And you definitely have long-term recordings that are being retained for multiple years to be used as evidence. Some recording solutions even capture your computer screen, either for triple confirmation, troubleshooting, or quality assurance purposes. You can be monitored and you can be observed what you typed as you were hearing it. Probably the most impactful equipment, though, next to your call handling equipment, is your CAD system, or computer-aided dispatch. This is the information hub where you, the telecommunicator, collect and process all of the information that's coming in from callers or field personnel. You might connect it with NCIC or any one of a dozen other integrations. It probably has a robust mapping or GIS system, and more than likely, it transfers your data out into a record management system or RMS once the event has been handled. It's probably also sending your CAD data directly out to field staff over a mobile data terminal, MDT, or a mobile data computer, MDC. Your GIS systems, particularly when used in automatic vehicle location or AVL systems, can be a huge assistant to your telecommunicators when the event is ready for dispatch. By plotting latitudes and longitudes of the events and comparing it with the locations of your possible responders, the system can plot routes and estimate arrival times to help select the closest appropriate units. And all of this could be offered up as a premises equipment as a service model. If we compare it to hosting the phone systems, this would be hosting in the cloud everything, including the CAD, the recorder, everything you need could be hosted in the cloud. Now, running all these systems and ensuring they keep running, a big part of that is going to be your building's electrical system. In addition to the line power coming in from the power company, your building probably also has a diesel powered generator to take over if the power fails. You probably also have uninterruptible power supplies or UPSs, essentially battery packs. These might be their smaller packs at each workstation connected to each server, or it could be a huge building-wide system, or both. Typically, a good UPS system plan is to cover powering of critical needs for up to an hour or two, which should be plenty of time to ensure that the generator is tripped and working. Beyond your call center, you might even find other equipment that ties together this public safety loop. I mentioned the MDC already. It's a fabulous tool for extending that CAD data out from your dispatch center and into the field. But how did you get the data back and forth from your center to the MDC? Well, one option is to use the radio system you already have for voice transmissions and include data in that transmission. This land mobile radio, or LMR system, might be completely under your agency's access and control, making it a secure option separate from the general public world. It is an option, but it's very limited. It has lower speeds, lower amounts of data, and restricted distances on transmission. More likely, particularly in a world dominated by systems in need of high-speed connectivity, large data amounts, it's probably connected to a cellular network. And quite common, especially since the Middle Class Tax Relief and Job Creation Act of 2012, it's probably connected to FirstNet, or the First Responder Network. And this is a specially configured and dedicated cellular network built for first responders. More about that in next week's class, talking about 911 systems. And that is a fairly, again, this is a brief intro, welcoming you to the class, giving an overview of the 911 system. And with that, I'm happy to take any questions, look for clarification, and discuss anything that I went too fast covering.
Thanks, Michael. And here I will just encourage people to ask questions. This is why we're doing it live, because you are definitely part of the process. And if you have a question about something, generally somebody else does, and they're just, afraid to ask. So please speak up and ask your questions, because it will only make the study session better. There we go.
Michael, great presentation. I wanted to ask about CAMA trunks again. Can you go over that piece and what CAMA stands for?
Oh, of course you're going to ask that. So the CAMAs and a lot of that background are actually going to be covered in a future class. Let me go back to that. Just one second. So CAMA stood for Centralized Automatic Message Accounting. And it was the, how to describe it. It was originally used by the phone companies for like toll calls, your pay phone lines, and they've repurposed it for 911 systems because it gave them a central location to kind of funnel those 911 calls and separate them from the standard phone system. They built it out to then include the 911 data, the Annie and Allie, and we're able to point them at 911 centers. So it wasn't the traditional copper phone line like your 10-digit phone lines. They were able to take the 911 call, move them into this separate specific 911 system, and transfer the call, forward the call through that selective router to the specific 911 center based on your CAMA trunk. Each line was dedicated to specific PSAPs so that it would be able to forward in this separate network. Does that help?
It does. Thank you.
Absolutely. Mike Radin from Boulder County.
Yes, Mike Radin from Boulder County. Can you hear me okay?
Yes, I can.
Two-part question. With last month's FCC approval of geo-routing for 988, is this tapping into the E911 system? And if so, it's my understanding that the 988 operators will not see Annie Alley, but if a call is transferred, that the PSAP will. Are you able to speak to either of those?
Unfortunately, I'm not. I know that those rulings came in. I know that they are coming. I can make some assumptions that they will probably use at least some of the technology that 911, specifically next generation 911 and the EZNets are using. But unfortunately, I do not have the details. Daryl, I see your hand. Do you have more details for us by chance?
Yeah, so as far as I know, there are no states that are going to be routing 988 calls on their 911 network. So it's not utilizing the same network. They're talking about routing calls essentially the same way that 311 or 211 calls are routed. If somebody uses one of those numbers on a wireless call, it routes it based solely on the cell tower location, and it's not routing it through a dedicated network like 911. As far as getting Annie Alley, if they transfer a call to you on your 10-digit line, you're obviously not going to get Annie Alley from that. If they have a way to route it to you on your 911 line, and there is the Annie component is transmitted with it, it could theoretically do an Alley bid on that and get the location of the caller. But as far as I know, that's not being contemplated in Colorado right now. I hope that helps.
Awesome. Thank you.
Thank you, Daryl. Claire Moody.
Can you talk a little more about the MSAG?
Sure. So the MSAG, it's essentially, let me go back to that slide for you. This obviously is an extremely oversimplified example. So in enhanced 911 systems, each PSAP boundary, as it were, is designated with an emergency services zone, which is assigned an emergency services number, essentially an identifier for the PSAP in that region. Between the phone companies and the MSAG authority, whether that's the same as your 911 authority, whether that's your specific agency, they're working together to essentially create a complete list of every single address point, every single street area, so that there's this picture a master Excel list that has and matches up every phone number possible in that region with every ESN, so that when the 911 call comes in, it's not in the legacy enhanced 911 system, it's not actually looking at a map and picking which PSAP is closest or which PSAP area you're in. It's essentially referring to this Excel sheet. It's referring to this list that says phone number 555-1234 is associated with this address, which equals this ESN. It routes it to that PSAP based on that table. Now, when we get into the next gen 911, there's a lot more going on as far as the mapping to try and kind of shore that up. But in an enhanced 911 system, that's what it's going through. It's going through this middle step of comparing a list and routing based on that list.
Okay, and is it the phone companies? They're the ones who are responsible for putting your address into the correct area?
Ultimately, yes, they are responsible. They are in control of that Annie and Allie controller. So in the overview of the system, if we look at this diagram, this where the Annie and Allie controller and the mobile positioning center, those are functions of the phone companies. And they can pool their resources. Typically they do, and they'll have regional Annie and Allie controllers that they're all sharing. It is the responsibility of the PSAP, if something gets misrouted and should have gone somewhere else, to work with them and clean up that NSAC. Anytime there's a new address, making sure the phone companies are aware of that location, working with the cell phone companies to make sure the cell towers are routing phone calls to the correct PSAP. But ultimately, the hardware belongs to the phone companies.
Thank you.
Absolutely.
Can I just add to that, Michael? So
Please do.
Another term that you might hear for that type of routing is tabular-based routing, because it is routing the call based on that table of phone numbers and ESNs, as opposed to what you'll see in next generation 911 routing, which is GIS-based routing. So if you hear those two terms, GIS-based routing versus tabular-based routing, they're talking about next gen 911 routing versus legacy 911 routing. And we'll talk more about that in future sessions, but I just wanted to have that extra term in your mind. If you hear that term tabular-based routing, that's what they're talking about.
Thank you, Daryl. Any other questions, comments, discussion? All right, well, thank you all so much. Don't forget to come back next week for session 2, where the amazing Jennifer Kirkland will be presenting PSAP external systems.
Yeah,
Jennifer,
looking forward to it, Michael. Thank you so much, and thank you all for being interactive and bringing your questions, because it definitely makes the session stronger. Michael, do you have anything else to add before we close out?
I don't. Thank you all so much for coming.
Thank you very much, and we hope to see you next week for class 2. Have a great night, everybody.
Thanks. Have a good night.
Thanks all.